Right. Last week we started chapter 7. And we did two things. We did multiplication and division of rational expressions. Okay? And I told you eventually we were going to do all four operations of rational expressions. And today we're going to get into adding and subtracting rational expressions. We're going to spend 2 days on this one as well because there's a lot of different types of problems in this lesson. And so today we're going to talk about some of the basic ones, and then we'll get into some that are a little bit harder and talk about how we can get into those a little bit tomorrow. Okay. Let's just start with a real basic one. If I were to add two fractions together, then what has to happen? We didn't need this last week, but what would have to be true? Yeah, the denominator has to be the same, right? When we add fractions together or subtract, that bottom has to be the same, okay? And so if it's already the same, then we're in good shape, right? And what we're going to find out is obviously it's not always going to be the same, okay? And there's going to be times where we're going to have to change the bottom so that we can do addition or subtraction. We didn't have to worry about that last week. When we do multiplication and when we do division, it does not matter if the bottom is the same or not. We could just multiply straight across. But with addition, it changes, okay? And some people would say, well, let's reduce this, but if I reduce 20 over 24, then would we be able to add them together? No. So there wouldn't be any good about trying to reduce it. So don't try to reduce 20 over 24, right? We're just going to add these two together. Now, when I add them together, what's the bottom going to be? It's going to be the same. It's going to be 24, right? And then I'm going to add the tops together. And that's our answer, okay? So if we already have a common denominator, then it should be a piece of cake, okay? Unfortunately, that won't always be the case, though. If I were to have one like this, 3/8 plus 5/6. Oh, I'll change these numbers up a little bit. Let's go 3/8 plus 4/5. I can't just add these together, right? What I have to do is I have to make the denominators the same. So I have to find something that both 8 and 5 will go into. So what would be something that both 8 and 5 could go into? 40, okay? And sometimes it's as easy as just multiplying them together. Sometimes there might be something smaller, but it's easier just to find something that when they multiply together. So in order to make this one 40, I got to multiply by 5. But if I'm going to make it 40, then I got to multiply both top and bottom by 5. I got to change the entire fraction. I can't just change the denominator. Over here, I'm going to multiply by 8 on top and bottom. So this would become 15 over 40 plus 32 over 40, which would become 47 over 40. Okay. And sometimes we get freaked out if we see a number on top that's bigger than the number on bottom. We just call that an improper fraction. Okay, it's no big deal. You could change it to like a mixed fraction or something like that if you wanted to, but just know from here on out, if we have an improper fraction, it's okay. It's just easier just to leave it like that. If I could reduce it, I would reduce it, but if it doesn't reduce, then I'm just going to leave it like that and be done, rather than trying to add another step to the mix. Okay, So these are just with numbers, right? And we've done it with numbers before, where we've added fractions. And so these are not rational expressions. These are just things that we've done before with variables or with numbers. But now we're going to add variables to the mix. We're going to add an x or a d or some other variable into the mix that we're going to have to be able to combine. Okay? What I'll tell you today is that I'm going to give you a lot of them that already have a common denominator. So today we're going to kind of start off with some of the easier ones, and then tomorrow we're going to get into some of the ones that are a little bit more complicated because they won't necessarily have a common denominator as we get going. Okay, so here we go. 3c over 2d plus 5c over 2d. Okay, and like I said, a lot of the ones that we do today will have a common denominator to begin with. When we get to the end, we'll have a couple that do not have common denominators, and we'll talk about what we can do to make them a common denominator. So because these already have a common denominator of 2d, we're going to add the numerators together, and we're going to leave the denominator. Okay, so the question here is, are we done?
And simplify. No, we can't. Never mind. Wait, can we?
That's a good question. Can we? Because it's a little bit different than last week.
They don't have the same text or the C and D.
Okay. But what's between the 8 and the C? Multiplication. It's not addition or subtraction. Okay. Addition and subtraction is what we saw last week, and we said in order to be able to simplify it, it has to be exactly the same thing on top and bottom. But the 8 and the C aren't necessarily attached. They're two different things. Okay. And so one way you could look at this is 8 times C over times D. The 8 and the 2 can simplify, okay? Because there's no addition or subtraction here. Addition or subtraction makes it an entire expression, okay? And so here, 8 divided by 2 would be 4, and all I have left on bottom is a D. So a little bit different when there's no addition or subtraction signs in there. So what we're saying is, yes, we can simplify this. Okay, and that's probably the hardest part of this whole chapter is when can I simplify versus when can I not simplify? When is it okay and when is it not okay? Okay, let's look at another one. The only thing different here is that we just have more stuff. Okay, what I typically like to do here is, as long as the denominator is the same, then we know that that denominator is not changing, right? So when I start writing my answer here, I'm just going to start by writing 2a minus 5b. Because I know the denominator will stay the same, just like all the other problems that we've done so far today. When I add two fractions together, the denominator will stay the same. And the only difference here is these are not just fractions, but these are rational expressions because we have variables all over the place. Now, what we said is we're going to add the tops together, but in order to add the tops together, we have to add like terms. So we're going to combine like terms. So if I were to add 4a plus 3a, I can add those two together, and that would make 7a. 3b plus negative 4b is the same as 3a minus 4b, which is, bless you, minus b. Okay, and when we get to this point, this, like I said earlier, this is the part that's hard. Can I knock the a's out?
No, because they're two different things.
Because they're two different things, right? What is happening here is 7a is connected with the b with a minus sign, right? Down here, 2a is connected with 5b with a minus sign. So in order to knock these expressions out, I would have to have a 7a minus b on top and a 7a minus b on bottom. It has to be the exact same expression. So I can't, if I just had this, I could knock the a's out, right? If I didn't have anything after those two, I could knock the a's out. But when I have that entire expression, then there's nothing else I can do here. I can't knock the a's out, I can't knock the b's out. You gotta think of those addition and subtraction signs as kind of a connector. That's what connects those expressions together, and that's what makes them different, okay? And so here, that's all we can do. That's it, okay? So in some cases, that's kind of a good thing, right? Because there's nothing else left to do, but the hard part is when can I versus when can I not simplify those expressions. Okay, and that's going to be the part that we have to really pay attention to. Hey, this next one is a little bit different. My denominator is a polynomial. Okay, it's a trinomial, in fact. Okay, here's the part that we got to be really careful of on this one. Okay, the difference here is that this one is a minus sign in between instead of an addition sign. Okay, that's going to be a really big difference here. My denominator is the same, so when I rewrite this one, immediately I can say, well, because the denominator is the same, we don't have to do anything to it. So we know the denominator is going to stay at c squared minus 5c plus 4. Okay, but when I take this minus this, what we're going to have to do, and what I kind of like to do here is I'm going to put a parenthesis around this because this minus sign here has to distribute to both of these. I'm taking c squared minus negative 2c minus 24. We have to distribute that to both parts because both of those come after the minus sign. So when I rewrite this, when I take minus a negative 2, what's that really going to become? What happens if I subtract a negative? 2 negatives make positive. So it's really plus 2c, okay? And then minus a positive 24 would become negative 24, okay? So when we get to this point, here's the question you're going to ask yourself over and over again, and that's why I keep saying it the same way, is when I get to this point, is there anything else that we can do, or are we done? Well, this is where last chapter is going to come into play. And I told you that we have to be really good at all of this, because if we're not good at factoring, then that's going to make all of this really, really difficult, okay? What can I do to both top and bottom? It's a trinomial, right? So what we have to try to do is we have to try to factor this trinomial. Is there a GCF on either top or bottom? No, okay? Are either one of them perfect squares? Well, 4 is a perfect square, but it would be 2 and 2, and 2 and 2 doesn't add to be 5. So neither one of those are perfect squares. So both of these are product and sum. And here's why we have to do product and sum. What multiplies to get negative 24 and adds to get 2? Okay. So we're going to rewrite this as c plus 6 and c minus 4. That replaces this. If I foiled those two together, it would give me that. Okay, on bottom, what multiplies to get 4 and adds to get negative 5? Zach, what you got? The weekend's over, man. Time to wake up. What multiplies to get 4 and adds to get negative 5? Shane?
-4, -1.
There you go, good. So that replaces that, okay? And here's why we have to factor it, because now if I look at top and bottom, what do I notice?
They can cross out.
They can cross out. What are we going to cross out?
C -4.
The C minus 4s, okay? So now we have a C plus 6 left on top. We have a C minus 1 left on bottom. Is it okay for me to knock my C's out here? No, because they're connected by a plus or minus sign. So this would be our answer, okay? So even though we have a common denominator to start with, that doesn't mean the problem's going to be a piece of cake always. We're going to have some factoring involved, or we're going to have some simplifying involved, and we just have to try it. Now, in some cases, we may get to this point, and maybe the two factors on top and bottom don't have anything in common, so then we may not be able to cross anything out, okay? But if we can, we got to try it. So we don't know until we've done the factoring. Okay, so I'm going to give you a lot of problems today that will already have a common denominator, and that holds true again here. Okay, we already have a common denominator. If it's not common, then it's going to make the problem a little bit harder. Tomorrow, that's going to be what we're going to see a little bit more of, is ones that don't have that same denominator to start with. And then what do we have to do? Okay, but that's what makes today's problems a little bit easier. The hard part is the top. I got to combine these two expressions together, okay? And I'm going to show you a trick here, and for some people this might make it easier, because trying to do it without writing it like this, for some of us, may not be very easy to do. So, for some people, it might be easier to do this. It might make more sense if you see it like this, right? Because if we see it like this, and I put parentheses around this, what's going to have to happen with the minus sign here that's in between? It's going to change it, right? We got to distribute it to the second parenthesis, not the first one, but the second parenthesis, it must get distributed, okay? And so I know it's a little bit extra step, but I feel like that might be a crucial step for some of us, just to see that it tells us that we have to distribute that minus sign. Because what's going to happen here is we see this minus sign, and what the most common mistake is people will do minus -6h, but then they'll forget to do like a -3 here. And this is not always going to be in parentheses, so I make it be in parentheses, so we know that we must distribute it, okay? So adding those parentheses to it, I think, is kind of a big deal. And so then we have, and once again, the denominator is going to stay the same. So what we're going to have here is we're going to have h squared minus 4h, okay? And then when I have minus a -6h, this really becomes positive 6h minus 3. Okay, we're going to combine like terms here. The two middle terms can combine. And then what we're going to do is we're going to combine, or to factor these two, to see if there's anything that's going to knock out. Okay? The one factoring that we're going to see over and over again is product and sum. Okay? So if there's one factoring method that you got to know how to do, it's probably product and sum. You'll see a slide and divide off and on. Not too often will you see perfect square trinomials. You might see some dots. But this is going to be seen more than anything else. Product and sum. You got to be able to do product and sum. So what multiplies to get -3 and adds to get a +2? Okay. H plus 3, H minus 1. On bottom, multiplies to get 21, adds to get 10. 3 times 7 is 21, 3 plus 7 is 10. And most of the time, I'm not saying always, but most of the time, it's going to be set up where something probably is going to cancel out, okay? I don't want to say all the time because there might be some times where that doesn't happen and I don't want you to think you did something wrong. But those two H plus 3s are going to cancel. We have H minus 1 over H minus 7, or H plus 7, sorry. And that would be our answer. So, a lot of common denominators today. One thing I'm going to do here today, before we get into what we do tomorrow, is I want to show you a couple of problems. And on these, we're not going to actually do the addition and subtraction of it. But you're going to see some problems like this today, where they're going to give me two expressions. And it's simply just going to ask me to find the LCD. What is the LCD of those two things? Okay. So if I did that, let's give you an example here. And we're not doing any addition or subtraction here. It's going to give me two expressions, and we want to focus on the denominator, and we want to figure out what is the LCD of those two denominators. So we've got to go one at a time here, okay? And we're looking for the lowest thing that both of these will go into. So like if I did 15 and 20, yes, you could multiply 15 times 20, but that's going to give you a really large number, okay? And so we got to find something that both 15 and 20 go into. And there's a couple different ways that you could go about that. One way you could do it, because we're looking for the lowest common denominator, is you could start listing the factors of 15, right? All the things that 15 goes into. So I'm just going to add 15 all the way down. 15, 30, 45, 60, and so on, okay? I could do the same thing for 20. 20 is probably a little bit easier, but right there. Those are our two common factors. And if you don't know that right off the top, that would be an easy way to get there, okay? And sometimes you may have to go for a while in your list until you find something that they have in common. But we got to have the lowest thing. That's why we don't just want to multiply 15 times 20 and get 300. 300 is a common factor, but it's not the lowest common factor, right? And so we got to get the lowest thing. So my LCD here is 60. Okay, A's. I have 6 A's over here. I have 4 A's over here. I got to figure out what is the lowest thing that they both go into. Okay? And when we did GCF last chapter, we said, what's something that goes into both of those? So we were looking for the highest thing that we could take out. Here, both of these have to go into the same thing. So if I have 6 A's here and 4 A's here, how many A's could they both go into? So when we did GCF, it was always the lower of the two. It was always 4. But when we do LCD, it's going to be the higher of the two. Because if I have 6 A's, this one already has 6 A's, this one needs 2 more to get 6 A's. Okay? It would kind of be like if I had 10 and 5. I don't need to go into 50, right? Because 5 goes into 10. And so 10 is a factor of 5. Same thing here for a's. A to the sixth and a to the fourth. We're going to take the bigger of the two exponents, which is a to the sixth. They both have 6 a's in common. And then b to the eighth and b to the fifth, which one am I going to take? B to the eighth. Okay, bigger of the two. Okay, so then not only are we going to find the LCD, but I want to rewrite these two expressions with that LCD. Okay, so we're going to make both of those fractions have an LCD of 60, a to the sixth, b to the eighth. So what I have to do over here, what do I have to multiply 15 by to make 60? 4, okay? So over here, we're going to multiply by 4. I have 6 a's. I need 6 a's, so guess what? We already have as many as we need. We already have all 6 a's. I have 8 b's, and I need 8 b's, so all I'm going to do on top here and bottom is multiply by 4. You don't have to change any variables. So this would become 16 over 60, a to the sixth, b to the eighth. Okay, for this one here, what do I have to multiply 20 by to make 60? 3. I have 4 a's, but I need 6 a's. So how many more a's do I need? 2. Right now I have 5 b's, but I need 8 b's. So I need 3 more b's. But I have to multiply by that on both top and bottom. Okay, and so then what that's going to give me is 27 a squared b cubed over 60 a to the sixth b to the eighth. Now my two denominators are the same, and it changed my numerator as well. Okay, so if we had to do addition or subtraction at that point, we could. But that's going to be kind of leading into a little bit of what we do tomorrow. Okay. One more here. 7r okay, and this, like I said, is going to lead a little bit into tomorrow. We're not doing any addition or subtraction on these last couple problems. All we want to find out is what is the LCD, and then we're going to multiply by that LCD. We're going to change both fractions, very similar to what we did on the last one. But this one's different because we have addition signs on bottom. So we got to do something before we can look for that LCD. What do you think we're going to do with both of our denominators, since we have a binomial right now? GCF. Yeah, we got to factor in both. Okay, so what we're going to do here, 9r plus 18, what can I take out of those two? 9. And if I take a 9 out, that leaves me r plus 2. So that is the factored form of 9r plus 18. We're just writing it in a different form. And I'll show you why it's helpful here in just a second. When we do the second one, what can we take out of both 15 and 30? 15. So we're going to take a 15 out. And when I take a 15 out, then we're left with r plus 2. Okay, what do we notice the two denominators both have? R plus 2, okay? So that's definitely got to be part of our LCD. R plus 2 is a common factor. They both have, okay? And then my coefficients are 9 and 15. So I got to find something that both 9 and 15 go into. 45, okay? And that would be my LCD. Okay, and then we're going to do this last step. I want to make the two LCDs 45 R plus 2. Right now, this is 9 times R plus 2. So what do I got to multiply by? 5. So we're going to multiply by 5. And if I do it to the bottom, I got to do it to the top. So this becomes 35R over 45 R plus 2. For the second one, right now I'm at 15 R plus 2. I need 45 R plus 2. So what am I going to have to multiply 15 by to get 45? 3. So this is 24R over 45 R plus 2. Okay. And as we talk, like tomorrow, when this is a plus or a minus sign here, then I could add these two together, I could subtract them together because they are like terms. If they weren't like terms, then we wouldn't be able to combine them. But if there was an addition or subtraction sign in between them, then we could combine those together and leave our denominator the same, okay? But those are definitely gonna be harder because we gotta force that denominator to be the same. But the good thing is today, most of the addition subtraction ones that you're going to do will already have that common denominator. But I kind of threw a couple of those in there as well, just because that'll kind of get us ready for tomorrow, but we're not actually doing the addition subtraction with it. All right, assignment for today. And we need to use this time we have here at the end to start working on some of these. We've been kind of getting slack on not using the time that I'm giving you here at the end. Some of you have been doing a great job of it, but others use it as social time. So let's try to use this to start working through some of these. If you have questions, I can help you. It's about 10 problems or so, I think. Just the evens. Pay attention to the directions as what's going on. When you get to the last three, 24, 26, and 28, then that's when you have, you have to find that common denominator. You don't actually have to do the addition subtraction.